on a whole new
Hey guys, today I'm going to talk about the theory between the geocentric and heliocentric models. So let's begin. So, geocentric versus heliocentric. Let's break it down first. We're looking at the word geo, which means earth. Notice the image below as we're talking about geo. Let's look at helio, which means sun. And let's look at the model where we're talking about the sun. Now, it's going to be reiterated and stated several times, but the geocentric model refers to the concept of the Earth being the center of the universe, whereas the heliocentric model refers to the belief that the sun was the center of the solar system, so to speak. So, let's begin. Ancient observations. The ancient Greeks observed the sky and noticed that the moon, the sun, and stars seemed to move in a circle around the earth. It seemed that the earth was not moving and everything in the heavens revolved around the earth. As it turned out, it was very difficult to prove that the planets did not revolve around the earth without leaving the planet. Wandering stars. The Greeks also noticed that while the stars moved across the sky, their patterns did not change. But 5 points of light did move among those stars. And if you can guess, those moving stars were likely to refer to planets. In fact, the Greeks called these objects planets, which means wandering star. They made careful observations of these planets, which included Mercury, Venus, Mars, Jupiter, and Saturn. So, the geocentric theory. Ancient Greeks, such as Aristotle, believed that the universe was perfect and finite, with the Earth at the exact center. This is considered the geocentric theory, which stated that the planets, moon, sun, and stars revolved around the earth. Ptolemy. Yes, the P is perhaps silent, so Ptolemy. In AD 140, the Greek astronomer Ptolemy revised the geocentric model to explain all the planetary motions. His model had the planets move in little circles that also moved in bigger circles. It's kind of a proposal of a loop-de-loop planet situation. And this belief actually persisted for about 1,500 years. Copernicus. In the early 1500s, the Polish astronomer Copernicus suggested that the sun and not the earth was the center of the solar system and the planets revolved around it. This is the heliocentric theory. So remember, Ptolemy and Aristotle were responsible for this belief that there was a geocentric model, whereas in the early 1500s, which is 1,500 years later, Copernicus proposed that the heliocentric theory model was the way that the solar system was set up. Helios again means sun in Greek. So problems with geocentric theory that led to this. So Galileo first saw evidence that objects revolved around something besides the Earth when he found Jupiter's moons. Galileo also saw that Mercury and Venus went through phases, just like our moon. The outer planets, Mars, Jupiter, and Saturn, however, did not. Heliocentric theory ends up prevailing, So Galileo supported Copernicus' theory, which clashed with the religious views of the time. He underwent many trials and tribulations and was even sentenced to house arrest for his remaining years. Because you have to keep in mind that for a long time, many people held this theory of geocentric model to be true, and it really takes a lot to change something that exists as a theory, as a standard of norm. His view has withstood the test of time. Today, we talk about our solar system and not our Earth system. So what's gravity? Because gravity is a force that holds a lot of these things together. So let's talk about it. Gravity is the force of attraction between any two objects with mass. Most of you guys are familiar with the concept of the apple falling on top of Sir Isaac Newton's head to familiarize yourself with gravity, but it does so much more. The more mass, the more gravity you have. The further apart two objects are, the less gravity. So what force keeps the planets in their orbits? Gravity acts on all objects on Earth and the universe and even you. There is gravitational attraction between the sun and each planet. This is why they circle this sun, which is a star. This gravitational attraction pulls the planets toward the sun as they move through space. Instead of flying off into space, the planets move in orbits around the sun. This completes our presentation on the solar system's view of geocentric and heliocentric models.